Hey everyone, so this is an online video to teach you guys lesson 2 in our chapter 1. So you should be given this handout from the sub and we will fill it out in this video. We're going at a pace like I'm by myself, so I'm talking through it. And so I would take the time to pause, like if you have any questions or if you need time to write out. Obviously this is through a video, so you can't see my handwriting it, so hopefully I can talk through as much as I can, and then I'll highlight when I'm talking about certain things. So let's get started. I already took the liberty to highlight each of the steps. I'm not going to go through them. If you want to pause to go through them, that's your business, but you can kind of see the steps that we'll be taking. It's already typed out for you that you can see it plain and simple and follow the steps on this example 1 and then all the rest to follow. So let's start off with number 1. During a camping trip in North Bay, Ontario, a couple went 1/3 of the way by boat, 10 miles by foot, 1/6 of the way by horse. How long was the trip? So we're going to start off with identifying the different variables and also just highlighting all the words. And it's not in the steps, but I just like to go ahead and do it. And then I'm finally going to highlight in this pink color the step 1 in our procedure, which is identify the question. So our question is, how long was the trip? That's our first step out of all of them. So I'm just going to go ahead and label number 1. How many miles was the trip? Okay, so that's our step 1. Our step 2 is now identifying kind of the yellow highlighted. So I'm gonna switch, let's see, I'll just do orange. So it's pretty similar, but let me highlight this. This is gonna be what we highlighted in yellow right here. So fix that real quick. Okay, so the identified parts here, oh, I do have a yellow, cool. Okay, so we have 1/3, and this is by boat, so 1/3 of the trip, and I'm just leaving it a blank because we'll talk about a variable in a little bit, but 1/3 by boat, we have 10, I don't like how that, let me fix that real quick. We've got 10 miles by foot. Let me just put miles down here. And then last but not least, we've got 1/6 of the trip that we have by horseback. Okay, so we've got our 3 numbers kind of explained to us right here. And so in our third step, we need to use a variable representation. So mainly when you're doing this, you're not going to have 1 and 2 written down that much unless it's really helpful to you. Step 3 is when you're going to start writing things on your paper because no matter quiz, test, homework, SAT, ACT, you need to recognize what variable you're identifying in your word problem. So we're going to say that, let me zoom in a second, the distance of the total trip, that's what we're searching for. We're going to use our favorite letter in math, X, and represent that in our equation when we go to step 4. So step 4 is the really important step that we got to make sure that we have the placement, all of our variables correct, and the numbers associated with our word problem. So starting off, our total trip, the distance of the trip was partially by boat, so it's 1/3 of the trip. And then we decided to walk 10 miles, and then we have 1/6 of that total trip being multiplied by X because it's total trip, and that equals our total trip. So in fact, on the left-hand side, we have partial fractions to represent our trip, which equals the entirety of X. Like we did in the last section, do you have to turn these into whole numbers? Absolutely not. You can do 1/3 plus 1/6 and subtract that from a singular X. But again, like I said, I like to because it helps us practice when we do rational expressions. So looking at our numbers, we have, dropped my pen. We have common denominators, or we don't have common denominators. Let's figure out a common multiple is what I meant to say. But we have, technically there's a 1 and a 1. So 3, 1, and 6. So if we're thinking of all the numbers, we're thinking, okay, common multiples of all of them are just a 6. So if I multiply 1/3 by 6, I'll get 2x. And then I multiply 10 by 6, because remember, we can't forget about the constant. A lot of us forgot that yesterday. You cannot forget to multiply by that constant. And then 6 times 1/6 is 6, or sorry, 1. 1. So that's just a singular x, and then I'm left with 6x. And that is actually step 5. So now that we have started to solve, we'll finish solving. So basically step 5 is completely solving, but we've gotten halfway. So combining like terms, I've got 2x on my left-hand side, and I'm going to combine those, but then subtract them off my 6x. So then I end up getting 3x equals 60. And so my actual answer is x equals 20. So what, x equals 20? That's great, that's awesome. However, I need to make sure step 6 is, aka the common sense department, realizing, hey, can I walk 20 miles? Yes, I can. So I need to make sure when I write my answer, I'm stating the trip was 20 miles long. And you know you absolutely can. What if you got a negative number? That's kind of when you're like, oh wait, I can't walk a negative distance, so something must happen with my numbers. So example 1 is a good slow way that will solve a problem when it comes to word expressions. These are all going to be, again, linear equations. So we're not doing anything with squared right now. We're not doing anything parabolas. We're not doing absolute value. We're just doing linear equations. So these all will be values of a singular x. We might find multiple values of x, but again, it'll just be a linear equation. So let's move to example 2. Example 2 is actually one of my favorites. Think of it as like a little riddle. When you first read them, you might become overwhelmed, but don't let that throw you. They're absolutely doable. You just have to be patient and understand the setup of these kind of situations. So find 3 consecutive even integers so that the sum of the 3 numbers is 2 more than twice the third. So like I said, a little like, oh my gosh, but just start by like the first 3 words or 4. Find 3 consecutive even, or 5 words. Find 3 consecutive even integers. So first think, okay, we know what integers are. Those are positive, negative numbers. We know what even numbers are, 2, 4, 6, 8, whatever. So if we're thinking about even integers, let's just think of an example of if I need 3 of them, well, how do I know what can I use to represent them? Well, let's just say we're going to use n to represent our number. Well, let's come over here and think, okay, well, I don't know how to represent the other ones, but I do know if I had 14, 16, and 18, those are consecutive numbers. So, and they're even. So from 14 to 16, that's plus 2. From 14 to 18, that's plus 4. So anytime you're adding and you're getting consecutive evens, you're going to be adding 2 each time. So we can come over here and use our value of n, but if we need to get to the next consecutive even number, we're going to add 2 to n, and that's going to be our second number. Then we do the same with the third one. N plus 4 is the third number that we're going to be finding. You could go all the way to however many you need. So, but right now we only need 3, so I have n. I have the second even integer, which is going to be 2 more than that, and then the third one is going to be 4 more than the original. So that's the first just 5 words. And so let's look at the next part. So this is starting off with an equation. The sum of the 3 numbers is. The moment I see is, I kind of want to stop because I know that's going to be equal sign. So I need to think, okay, what's in front of my equal sign? What's on my left-hand side? Oh, I meant to highlight is, not to. So, 1 second. Is, okay. So, the sum of all 3 numbers. Well, I know what sum means. That means addition. So I'm going to add all my numbers together. So I have n. I have, we're going to put parentheses, I have n plus 2. And I have n plus 4. Okay, so that's the left side of my equation. And then I know I have an equal sign is. Let's do the second part. And I'm going to highlight, just so you can see kind of like the breaking up of them. So is, and this is the right side of my equation, 2 more than twice the third. Well, 2 more than twice the third. Let's think about that. We know 2 more is just, think of 2 more M&Ms. I got 2 more of them, so I'm adding 2. And hopefully it's okay, but I'm gonna go ahead and erase this so I have more room to work. And then, so 2 more, so 2 plus, if we're talking about differences, don't forget differences, that's subtraction, so it's gonna be after, but addition is just adding to the total. So 2 more than twice the third. So twice, we have 2, but it's our third number. So we need to make sure that we're grouping our entire third number in parentheses, and then that's it, we're done. That's our full equation for our linear application problem. So now let's solve for what that number is, our mystery number, if you will. So we have 3 n's, so 3n. We have 6 equals 2, and then 2 distributes, so it's going to be 2n on the right-hand side. 2 distributes to this 4, so I have 2 times 4, which is 8, and then plus 2, which is 10. So left hand and right. Left hand, left side, and then right side. All right, so subtracting 2, I get a value of n, and then subtracting 6 from 10, I get 4. So that's my value of n, my first number. However, it asks for the 3's consecutive. So my real answer is going to be 4 and 6 and 10. And this is my final answer right here. Cool? I would pause the video now, just think if you need to think anything. If you have any questions, you can write them on like a piece of paper, a sticky note, or email me if you need them answered right away. But hopefully this helps you. All right, so example 3. A rectangle, 24 meters long, has the same area as a square with 12 meter sides. So we're talking about a rectangle and a square. I'm going to change it up, like purple or something. So we have a rectangle, and then we have a square. They told us that our square has 12 meter sides. And if you remember the definition of a square from geometry, a square always has congruent sides. So if it's one side's 12, the other side's going to be 12. And then this rectangle has a length of 24. But we don't know the width because remember, a rectangle is not a square. So if we are trying to find the area, they tell us that it has the same area. That should be a key to you, because if you think if it has the same area of the square, that means if this is 12 by 12, area is just length times width, so 144. So that means this area is also 144. So if you remember the area formula for a square is the same as a rectangle. So area equals length times width. Well, we know area because it's the same. So 144 equals, we know the length is 24, but we don't know the width. And so we solve by dividing. And so my area for the width is 6. Pretty neat, right? I think it's simple when you create a visual. Again, I know I'm always a visual person, but these really help you. It helps you represent the difference or not difference, but what problems can aid you on one. Like if you're working slow and you're doing stepwise, you'll realize that you have a lot more information to work with once you've written it out. And sorry about the noise, it's my water heater. All right, so we found the width is 6. So then now it's asking what are the dimensions of the rectangle. Well, we did answer that, but we didn't answer that in a full sentence because it's a word problem. We want to say it in a full sentence. So we can say the dimensions of the rectangle are 24, is it meters? Yeah, 24 meters by 6 meters. Okay, the dimensions of the rectangle are 24 meters by 6 meters, and then we're done. All right, so So normally this is when I would pause in class, and we've done all this front page and we've done all this part, example 2 and example 3. I would say if you want to pause this video, I would do example 4 by yourself, and I would also do example 5 by yourself. Okay, so I would pause it, I would take your time, I would do example 4, but now, hopefully you pause, and welcome back. Hello, if you took a pause and you're coming out back now. So I'm gonna talk through example 4 and example 5. So with more like explanation of the problems, because hopefully we're getting it with example 2, example 3, and I'll do a more fluid explanation of the problems so I don't seem like a broken record. So let's highlight. Now I'm just normally just gonna highlight the important stuff, so we'll do blue this time. So 2 consecutive even integers, and then I'm gonna break it up from the equal sign. So 4 times the smaller number is, we know that's equals 2 more than 3 times the larger number. So instead of 3 digits, we're actually only finding 2. So if we have n equals a number, right? And then we're gonna have n plus 2 equal that second number. Because this time we only have 2, and it is even still. Even if it was odd, remember, even it's every other, odd is every other as well. So it'd be the same regardless if they ask for even and odd. Don't let odd freak you out when you do see it. So left side of the equation, 4 times the smaller number. So 4, my smaller number is just n, is always equal 2 more than 3 times the larger number. So again, addition, 2 more. 3 times the larger number, 3 with, again, parentheses, because you gotta have that in grouping. You're gonna throw your larger number in there, and this time it's just 1 right after it. So n plus 2. Okay, now this is my equation. I zoom back out just so you can see it. So 4n equals 2 plus 3n plus 2. Now we're gonna simplify. I'm just gonna rewrite this without the parentheses because do we really need them? No, but again, it's nice to see it once you're plugging it in. So 3n plus 6. Combining like terms, I'm just gonna subtract a 3. So I have n equals 8. So my smallest number is 8, and I also have a number 2 consecutive even integers, so it's not only 8, but it's also, hopefully you said it in your head, 10. And this is my answer. We can highlight it a little bit too. Cool, awesome, great. Okay, so since you paused, you probably have example 5 too. In an NFL playing field is a rectangle. The length of the field, excluding the end zones, is 40 more yards than twice the width. So this time we have a rectangle, and we have been told that the length is 40 more than twice the width. So the length equals 40 more, and then what was it? It was twice the width, 2w. And then obviously w, we don't know. However, what they did give us was the perimeter of the playing field is 260. Well, rectangles have 2 sides that are equal to each other and 2 sides that are equal. So this side is also 40 plus 2w. Oop, I put a 4 for some reason. Hold on. 2w. 2w. Okay, so there's a couple ways you could do this. You could write out your perimeter, because perimeter, remember, is length plus width, or if you remember it just being 2L plus 2W, 2 length plus 2 width. So instead of just adding it the long way, we can say 2 times 40 plus 2W, and then plus 2W equals 260. Okay, so I can distribute out and solve. So I have 80 plus 2 times 2 is 4. So then I end up with 6W equals 260. Subtract 80, divide by 6. We get W. Oh, my pen didn't want to work. Hold on. W equals 30. Cool. All right, awesome. hopefully you got that. And if you didn't, just think, okay, maybe you did twice the length, maybe you forgot to add the width on the end of it as well, or maybe you just didn't think of perimeter, you just did area. So a couple of small mistakes you can make. Now that we find width, well, that main question, that step number 1, we can't ever forget about it, is that first question that's being asked. What are the dimensions of the field in yards? Well, the field is 30, and it's in yards, so 30 yards by, oh, we forgot to solve for the length. So we need to go back, and we have 30 as a width, but the length is 40 plus 2W. So I'm gonna get a different color just so I don't get confused. Okay, I'm gonna come over here. And so length equals 40 plus 2 times 30. So that's gonna be 60, and then I have 60 plus 40, so my length equals 100. So I'm gonna come back here. The field is 30 yards by 100 yards. Okay, cool. All right, I'm gonna zoom back out. Pause if you have any questions, or read it, rewrite it, anything like that. All right, if I hopefully lost your attention, if it's one thing you pay attention to in this video, hopefully it's example 6. Lots of interest problems that we're gonna do tomorrow, which is gonna be the second part of lesson 2. So let's start with example 6 and just start. So a builder of tract homes reduced the price of a model by 15%. If the new price is $125,000, what is its original price? How much can be saved by the purchasing model? Well, most of these questions, most all of them, are going to be in order of where you should solve. So the first thing we need to solve is what is the original price. We don't want to worry about what I'm highlighting in green. We don't want to worry about that just yet because we don't actually know the original price yet. So a builder of a tract home reduced the price of model by 15%. So let's just say that my price is, because we don't know my price, right? This is the original, oops. Original price. Okay, X is my original price. So when I'm going to solve, I'm thinking, okay, well, the reduced price is 15%. So think of the value of the entire house. So that's X. If it's reduced, think about it, I'll pause. What operation explains reduced? Hopefully you said subtraction. Subtraction it is. So if I'm subtracting and reducing 15%, make sure you're not putting 15. We need to put 0.15 because that is a percent problem. We've got to make sure when we have our linear equations, we're using percents, and that's when we turn them into a decimal when we're talking our word problem. We don't want to put 15. That'd be kind of crazy. So we are reducing 15% off our new price, and the new price listed is $125,000. So what we're going to do now is solve for X. We want to find the original price. So 1X minus 0.15X is 0.85X. Sorry, I'm getting a little messy. Equals 125. And then once I have that, I divide both sides by 0.85, and my original asking price, and I'm going to put it in dollars because we're talking dollars, is $147,058, or sorry, $147,058 and then 82 cents. All right, we always want to round to the hundredth when we're talking money because we don't do 10/100th place when we're talking about money. We're talking about our 100th place. So that's our original price. That's what we want in blue. That's what I'm going to highlight because it matches the question being asked in blue. But we were also asked a question in green. And that question in green is how much can be saved by purchasing the model? Well, if I originally had an asking price of $147,000, but I ended up paying $125,000, I can think about that money I saved. So that also is going to be a subtraction off. So I'm going to have $147,058 and 82 cents, subtract 125,000. And then you can put 0 cents if you'd like. So then my answer is going to be 22,058.82. So when you're doing this, make sure you're not like adding or anything like that, because that can mess you up. And then making sure we're subtracting, because we are asking not for the difference, but the money that you save, which is still considered the distance, or not distance, the difference in the two numbers. So 22,558.82 is going to be how much we saved, and I'm going to highlight that in green. Okay, so also, all right, money saved. Money saved. And then because we have X as original price, this is original price if you need it to. All right, and that is lesson 2, chapter 1. I know it's weird watching a video about it, so hopefully you retain everything. If there's any specific questions, just make sure you ask me tomorrow in class, and then we can take a short period of time overviewing that. But we're still going to do more problems like this in the second part of lesson 2. And that's all. Thanks, guys. I really appreciate you taking the time to watch this. If you can't watch it all in class, that's fine. Watch it at home if you need to break it up, but you should still be productive in class and watch the video and or do your delta math. All right, thanks, guys. Bye.